Do you know of any that have been done in the South yet? Because that would be cool to have ones in the South as well, of course. I wouldn't imagine it would be any different though. I mean, why would it all of a sudden just start giving a globe result in the South? That'd be the weirdest thing ever. If it all of a sudden just the shape of the Earth changed when you go south.
Yeah, I mean, there's a lot of Aussies that come in here. Put them on a mission. I'm gonna get Rick to do it.
Well, I like the way you said it. Like it can be easy enough to where, like, if you at least know. Well, it seems like the basic things you would need to know is where you are, the mountain peak, and then just at least like a star that you're gonna, that you can then boom, and then you time that, and like once you have that, then the rest of it, you can do the rest of it.
Basically, what Dr. Mike did at first was just stare at the mountain peak and just waited for stars to get occluded by it, marked down the time, and then went into Stellarium to see which stars are actually occluded. So you can do it either way. You can either get the star ahead of time or after the fact. Either way, you're basically just staring at a mountain and waiting for a star to go behind it. It's so simple. That's what makes it so great, and anyone can reproduce it too.
Yeah, you're saying you could just start with the time. You could be like, hey, at 11:52 and 41 seconds.
Yep. Then you take, like, literally, I tested this with Stellarium. You take that time, you put it in Stellarium, then you put in the coordinates of the mountain peak, and then you could see what star it was. And this, Stellarium has no idea where you were observing it. It's just giving you the elevation angle from the peak to the star. That's what makes it so beautiful.
So maybe if you did it that way though, like after you get it, like if you just take the time and then you go get the stars, maybe you would want to learn what the star is a little, and then zoom, look at it and make sure, you know what I mean, and then watch it occlude, right, to get like a double check on that. If you're gonna do it that way, probably, like you'd want to. Like I'm just saying, if you just took a time and then you went to Stellarium later and looked at the stars, it seems like to make sure that it did occlude at that time, you'd then want to track the star, then maybe do it a second night just to make sure it occludes right at that time. Because the first time you just took a time, like if you just literally randomly say, I'll take this whatever's occluding at that time, at just any random time. But yeah.
Well, I'm saying it just depends on, like, because when you look at Dr. Mike's videos, right? There's only certain stars that are bright enough to even see them get occluded, right? And in Stellarium, what they do is they make the star huge in terms of to show its brightness. So like it's pretty easy to see it afterwards. Like me and Alan were going through all the stuff and like basically creating the screenshots, and dude, it was so cathartic, like going over all the data and all the tables and basically going one by one, looking at the time, confirming it's Stellarium, see if it matches the angle. It does. All right, cool. Make a screenshot. And so on and so forth. And we did it like 17 to 20 times. And then Dr. Mike comes out with even more observations of different peaks from even further away to show the discrepancy between globe and flat. It's beautiful. It's not just a coincidence at this point.
All right. So how about this? What if we can just maybe go look at some camera footage, or we go scour some videos looking at a particular mountain peak? We can maybe try to figure out what star they're looking at, if there's like a timestamp, and then we can just do it that way. We don't need somebody to do it. There's probably already footage out there.
You'd have to know the distance that person is from the mountain peak. You'd have to know. You'd have to know the distance.
We'd have to know the viewing area. Yeah.
But you really have to know the distance, though.
Well, if we know where they're at, because it's listed in the description, we could see what mountain peak they're looking at, right? I don't know. I just imagine that maybe there's something out there. It's like we could just assemble these from videos we find.
Well, in maybe a semi-joke way, I'll say like you could probably put AI on that. Tell AI to go through all its metadata of every photo ever and calculate it. Yeah, give it all to you in a spreadsheet. No, but seems like with this, you do need to kind of have some. There needs to be some like confirmation of like some of the factors. Like just pulling it from like pictures and stuff seems like that'd be tough unless you knew all the exact information of where they were for sure when they took it. Plus, you kind of have to be zooming in to look at which star, at least to a degree, right? I mean, I guess you could somewhat see with the naked eye, depending on what star it is. But
the thing is, with distance, you're gonna have a great camera or telescope. That's the thing. You want to have enough distance to show the discrepancy between globe and flat. Otherwise, you're just
Yeah. What kind of distance do you need then?
It really accentuates the distance. I mean, just to give you an idea, so the 50.7 kilometer distance between Pikes Peak and Mike's house, the difference in arc minutes is 27 arc minutes.
So 50 miles or 40 miles or something?
50 kilometers.
Okay, so 30 miles.
Right. And then that's like a 27-minute arc difference between globe and flat.
Tell me where I can watch the videos that you're talking about with the data.
I think Alan's going to present it tomorrow to Jaren, like all the videos. I could post a link. I can repost a link for you.
Yeah, that'd be great. I appreciate it.
It's valid until the 24th of March, but yeah. Post it in live stream.
Appreciate that.
Those are the new ones, by the way. So I don't have access to the old ones, but I could ask Alan later.
Yeah, no worries. I'm just trying to understand the argument. Appreciate it.
Yeah, I mean, yeah, it's really cool. So take any mountain peak, right? You have a known distance away from it. The farther, the better. And you just make like a calculation. right? So you have the elevation of the mountain, the distance away you are from it, and that completes your triangle, right? So whatever angle that is. And it's just a calculation. No measurement yet, just a calculation. And then to confirm that angle, you basically observe the mountain peak. You wait for a star to get occluded by said mountain peak. So then that way you could take refraction out of the equation because it's physically blocking the starlight. You take that exact same timing, right? You're like, boom, clock it. Clock that time. Then you take that exact time and the coordinates of said mountain peak, put it in stellarium, and then look at the star that was just occluded, and then you see the true position of the star. You can take off atmospheric refraction in stellarium because that's what the apparent position of the star is. That's not what we want. We want the true position. When you put on the true position, it literally matches the flat prediction every time. That's the crazy part. It's not just a coincidence with just one peak. It's like 6 different peaks, like 40 different observations now.
You're saying it doesn't match the globe.
No. There would have to be a certain amount of globe slant in between you and the star, right? And it's very noticeable the farther away you get. Because on the globe paradigm, the ground's curving away from you, essentially tilting away from you. And that timing of when the star would get occluded would be different. And so far, haven't had any globe math match up. It's been,
All
what,
right.
3 weeks, Gio? 4 weeks now?
Appreciate it. I'll definitely look into it. I'm interested in it.
Did Ruhif end up buying someone's time to go measure those things?
I'm not sure.
I mean, I heard that he did. Like almost right away, he said, "Okay, I'm going to send a guy out there."
Yeah, I mean, the thing is, what Ruhif is trying to make the argument about is the measurement to the peak itself with the theodolite. That's not what's in
Mhm.
question. Like Mike even said, like, hey, this matches the globe when I use the modern theodolite, and it matches flat Earth when I use the level transit. How can I differentiate between what's accurate? That's why he came up with the celestial theodolite concept in the first place. So I mean, all right, so what? The measurement from you to the peak is different. Big deal.
Well, the fundamental question is whether there is globe drop or not. And if there's globe drop, then the visual elevation of the peak from Heffron's house is 2 degrees and 19 minutes. If there's not globe drop, if it's a flat Earth, then the elevation of the peak from Heffron's house is 2 degrees 31 minutes, something like that. So that's the question.
Yeah, but how can you differentiate between refraction and globe curve? That's the
Well,
other question.
the nice thing is that, number one, that's why I created the small nearby hill example.
It's
But
not
even in the
analogous.
case of Pikes Peak, you can completely forget about refraction from Pikes Peak to Mike's house. That makes less than 2 arc minutes of difference. And the difference between the globe Earth predicted elevation of the peak and the flat Earth predicted elevation of the peak is 11 or 12 minutes.
Yep.
So there's a much bigger difference there. And the elevation of the peak calculated on the globe Earth is 2 degrees 19 minutes. That agrees with the theodolite measurement of the elevation of the peak, and that agrees with the visual elevation of the star from Mike's house at the time of the occlusion.
But you're basically bringing it back to the age-old argument of using a theodolite and seeing the globe curve beneath you, based on refractive indexes and stuff. And it's like, you're just going to go back and forth, back and forth. It's like, how can you confirm the difference?
Why would you give him refraction? I hate that. Why would you give him that?
Well, that's
why
the
do they
point.
get refraction to begin with? It's not even a thing without the 2 mediums. I don't know why anybody.
But that's the thing. It's like, how can you confirm what is correct, right? We say it's visual space, right? It's curved visual space. You guys say it's Earth curve. All right. So now we're at an impasse. So how can you get beyond that impasse, right?
Well,
You would have to have something that's mutually exclusive. So
once
far,
again, the
celestial theodolite is mutually exclusive to flat Earth because you guys haven't presented anything.
No, it's not. I'm a big booster of using stars to determine elevations. As soon as I heard of this method, I thought, my God, I can't believe they're doing this, because if you do it right, which is to say, I mean, it's a very simple matter, right? What we want to know is, what is the visual elevation of the peak? And what better way than seeing a star being occluded and simply asking, what's the elevation of that star when it's occluded? That's all you do. So if in the globe Earth method, basically we have ways of predicting when the occlusion will happen. The globe Earth method predicts that the occlusion will happen when the visual elevation of the star from the observation point equals the visual elevation of the peak from the observation point. That's how we predict the occlusion time. In the flat Earth method, the flat Earth method is to predict that the geometric elevation of the peak as calculated on a flat Earth should equal the geometric, that is to say, invisible position of the star
What are you talking about,
from
dude?
the peak at that time. Because the visual elevation of the star from the peak is 2 degrees and 42 minutes. If you were
Apparent,
on
that's
the
with
peak,
atmospheric
you
refraction.
would
You're just
see. That's what stellarium tells you. We're depending on stellarium, and stellarium tells you correctly that if you were on the top of Pikes Peak, you would see the star at that time at 2 degrees and 42 arc minutes.
okay, what's more important, the apparent position or the true position?
Well, I'll let you decide. When you're
I'm
looking at a
asking you.
star,
I'm asking you the
okay,
question.
from my point of view, if you want to know the visual elevate, you're looking at a star and you want to know how high is
Could
that
you
thing that I'm looking at.
could you please just
Stellarium
answer
tells
my
you,
question?
and that thing you're looking at is
Jesus
2
Christ.
degrees and 42 minutes above the horizon.
Can you just answer my question, please? What's more important to you, the true position of the star or the apparent position?
The apparent position is more important to me, and the reason is
Why?
because that's what you point your theodolite at.
What the hell?
Yeah, but the actual position is what you would do geometry with, not the apparent position.
Exactly, Jeremy. Exactly.
Right. Why the hell would you use apparent? Like that's you're just fantasy. It's not real.
Settle down,
It's
bro.
apparent.
That's like fixating your theodolite on like a guy's head in the pool, right? And then you're like, okay, that's the true position. But then where his body's at, like it's like this weird optical phenomenon going on. But if you were to go to the body, then you would be way off, even in your what you're trying to prove. That I don't get you how you want to go apparent, dude. That's really weird.
You know why they want to go apparent? Because then they can bring back the globe through refraction.
Yeah, it's where their
It's
magical
very obvious.
horse shit. It all happens. Their magical horse shit happens. Their fake refraction. It's not real. It's not even thing. It's not refraction. It happens at a boundary between two mediums. It's not two mediums, so you don't have refraction. Whatever the hell you guys want to, you shouldn't even be using the word refraction.
It sounds like that's where they get to pencil whip it, and then they just make it fit. Oh yeah, we calculated. Oh yeah, we predicted
Exactly.
that. That's what it's supposed to be because we calculated it after they did like 10 shots and they took a medium from them and said, oh yeah, that's exactly what we wanted. Like these guys don't get it, dude. I don't know who these morons are, but whatever.
Isn't the whole point that like once it's occluded, it's no longer being refracted, so it's taken out of the equation, so it doesn't matter.
Exactly. Yep, that's exactly the point. But they have nothing else to go by because it's. I mean, this is 40. Let me get the exact number. I don't know what the exact number is right now, but it's like 40 different observations, and they all match flat Earth predictions. So unless you guys can show where it'll match a globe prediction, then there's nothing to talk about. That's why it's mutually exclusive at this point in
So
time.
have you shown that it doesn't match the globe prediction?
Yes, I've seen it.
I don't think you have. Can you steel man how a globe, how I would predict the time of the occlusion?
Okay. If I'm looking at a mountain peak, I see the star get occluded. All right. In globe math.
No, I'm going to predict. I want a prediction. How would I predict the time of the occlusion?
Okay. In globe math, you have a 27 arc minute difference between when the star would get occluded and where it actually is. And that's from Mike's house to the star.
Well, you're not telling me. I want you to steel man what I would do to predict the time of the occlusion.
What you would do to predict it. I mean,
because I can steel man what you do to predict the time of occlusion. I think until you can steel man what I would do, I think you're arguing from a deficit. We need to understand each other, and I thoroughly understand your method.
okay. So have you refuted it yet?
Well, yes, I have, but not experimentally. So I get that. I mean, I'm perfectly happy to say no. I haven't experimentally. I can tell you why it's wrong, but you won't believe it. But all I'm saying is that going forward, what we need to do is have people from
Hold on,
both
why is it
sides
wrong?
predict the
Wait, wait.
times. What we
Wait,
need
wait.
to do is predict the times, because the times we predict will be different. Now, often, as in the case of Pikes Peak, they won't be different enough to make a clear distinction. But in the
Hold on.
case of a
Why is
small
it
nearby
wrong?
hill, they will be.
Before you continue on, why is it
Yeah.
wrong? You said, I know why it's wrong, but you won't believe me.
Yeah, no, it's
Try me.
wrong. It's
Why?
wrong because what makes the occlusion is the light from the star, which is moving toward your eye, that goes along a curved path. That light travels along a slightly downward curved path. That path, the path to your eye, is unoccluded for a while, but as the star gets lower and lower, there comes a point where that curved path is occluded by the peak. And at that point, the light no longer makes it to your eye. And that's when the occlusion happens. Your method doesn't take that into account, and mine does.
You need to draw that as a diagram, bro.
But once again, I'm waiting for you to steal. I can tell you if you can't steel man it, you can try to learn it so you can steel man it.
Yeah, I actually do want to do that. So can you make a diagram of that? What you just
Yeah,
said?
I have made a diagram.
Where is it? Where can I find it?
Well, it's I shouldn't say. I mean, Rufy made it. I put it in the chat a while ago. I'll put it in again.
Yeah, please.
Hold on.
You said you've got some Australians that would be willing to do the same sort of observations in the South.
Sure, I don't know what difference that makes, but that would be fine.
I would contest that it couldn't be done.
Why is that?
Why?
Well, the diagram that who was it that posted it? Riggs earlier.
That's.
I'm not sure I'm totally steel manning the claim. That's kind of why I was prodding. Like, it seems like in some respect this is reverse engineering maybe how they assembled their refraction model or their claim, but I'm not sure exactly what it proves in regards to like determining exact positions on a flat surface. You know, so I'm not sure exactly if South proves what I'm even talking about.
Well, Riggs, what it shows, if you take it further, right, the implications, and if we get more people to do this celestial theodolite across the Earth, right, in all different places, all different locations, to me, what it would prove is that they took flat Earth elevation angles to stars to create the graticule in the first place. Like, this is how they did it. They basically took flat baselines, right, took elevations to the stars, and then reified it to a graticule and said, this graticule is now the globe.
So it would be removing like some terrestrial refraction from the claim, but perhaps not celestial refraction.
Yeah, like Dr. Mike had an example 2 weeks ago or a week ago where he said, okay, imagine you take, like a tongue depressor or whatever, right? Like a popsicle stick, and you had a laser light and you were shining it through a saltwater tank or whatever, and you would see the laser light be bending down towards the denser medium. Well, if you take that tongue depressor and imagine that as a mountain peak, it's the same kind of concept. It doesn't matter how much it's curving down. You're basically taking the timing of when that laser is basically getting occluded by said tongue depressor, and it wouldn't affect the angle at all because you're just using a physical object, right? Like if I'm an observer on the other side of the tank and I wait until that laser light is no longer visible, it's getting blocked by the tongue depressor, it doesn't matter. Like you're basically using that to find out exactly where that laser light originated from. And that's the point, right? You're basically taking the true position of the star. Doesn't matter how much it's curving, doesn't matter, none of that matters. Because you're basically taking the midpoint between you and the mountain peak, or you and the star, and using the mountain peak to confirm the angle. Hey, guess what? It's flat.
Well, okay, so all it's proving is that you get the same angle on a flat surface. But that the thing is, like in my head, that to me tells me I'm getting like an exact location of the star, and if you get enough of those, then well, that's okay. This is the problem that So if it's like in one respect, it's proving the surface is doing. Oh, I wouldn't say it's proving, but it's supporting our argument because you can't do it on the globe that way.
I'm looking at.
But on the other hand, though. No, because you need to have terrestrial refraction in order to make the angles line up the way it's supposed to. But on a flat surface, like you go to the top of the mountain and you turn refraction off, and that's how it works, and the angle stays the same. So,
right,
like,
I'm looking at.
I think that's highly coincidental.
It's not a coincidence.
Does that mean it's establishing?
Times,
huh?
It's been done 40 times. It's not a coincidence. It's not just one mountain peak.
Well, is it okay? Has it? Well, no. I know what you're saying, but like coming from the globe point of view, highly coincidental. Like they would have to be like, what's this bullshit? At some point they'd have to say that.
This is coincidence. I'm looking at the picture that Dr. John posted. If the measurements are all matching up observations are all matching up with the flat Earth, and what he's saying is actually happening, then celestial in his diagram, and basically this is an honest steel man, even though it's ridiculous. The celestial refraction will be making up the difference and making it look as if every observation is on a flat Earth.
Yeah, celestial. Sorry, I misspoke earlier.
Yeah,
Yeah.
Yeah. So let me. Can I describe those? If you take a look at those diagrams that I put in the live stream.
We understand. Pretty self.
So the important thing there is that just before the occlusion happens, the light from the star is entering the atmosphere, curving downward. It's passing just above the peak, and then it's coming in eventually to the observer's eye. And of course, that red line, this is the part that I think a lot of people don't really understand. That red line is tangent to that yellow, the orange, whatever, yellow line from the star at the observer's point. If I were to zoom in on the observer, that yellow line would look straight and it would be exactly parallel to the red line right there. That's the direction that light comes into the eye at. And it is therefore where the eye sees the star. Not only the star, but the mountain peak. The mountain peak appears there too. Okay, is that clear?
Yeah, we get that. But do you agree that then the celestial refraction, if the measurement observations minus the curved refraction component, if the observations, if you just take basic trigonometry, are matching up, right? Are matching up.
No, they won't. No, I know that they do. I know that they do.
Not listening. Listen to what I'm saying. If the observation, so I understand your diagram. Like your diagram saying that light is celestially refracted.
Does everybody? Can I just ask if everybody understands my diagram?
Hold on. Just go back before the baboon, bro.
If someone says that they don't understand it, you're just gonna like derail this entire exchange. Like, wow.
Okay, go ahead.
All right. So I understand your diagram. Your diagram is saying that like the light is celestially refracting in such a way that it appears, because of the way it bends, it's already been occluded, but in the way that it bends, it appears as if it's already above. It's still above the peak, but in reality, it's already been occluded physically, geometrically.
No, that's wrong. No. Geometrically, okay, fair enough, right.
Well, you don't listen, bro. What the fuck is with you guys, bro? Holy fuck.
Well, you said it had been occluded, and it had not been occluded. Then you said geometrically. Okay, fair enough, but that's not occlusion. Occlusion is visual.
1 second, the apologetics AI in your brain was so quick to jump to like some sort of a rebuttal that there was a lag where you didn't hear my word geometrically, and then it registered, and then you're like, oh shit, yeah, geometrically. So just don't be that way, okay? So going back to the point, so geometrically already occluded in your model. And now it's being celestially refracted down in such a way that the angle looks like it's now still above. The angle which enters your eye makes it look as if it's still above and not yet occluded. Correct?
Right.
Okay, and now here's the if. Now putting your model aside for a second. If it is the case that the observations match up with the plane trig true position on a planar Earth, if they accurately match up with that, then then the celestial refraction will be happening in such a way that it coincidentally, every single time in all these observations, if they're all true, match up with the flat Earth prediction for the true position with plane trig.
Yeah, no, I guarantee you that won't happen.
What are you talking about? How about 40 observations now, John?
No. I'm not saying that. I do. I'm a little skeptical. I want to look at those other observations too. 50 kilometers is kind of the sweet spot for things working out, just because that's the place where the globe curvature matches the astronomical refraction. So I get that. But my point is that the globe Earth calculation.
No, don't you find that suspect at all?
Not at all. Because here's what I think actually happened. Dr. Mike is an astronomer. He does telescopes and things like that. I'm sure he came up with this celestial theodolite idea, thinking, "Oh, this is cool. I can use stars to check, as a theodolite." And so he said, so I'm, I'm almost sure.
John, stop.
Okay, all right, never
stop,
mind.
because you're lying right now. Stop.
No, I'm not. I'm telling you what I think happened.
Told you many times Mike's origination story. Many times. He was trying to help Taylor out because he was hearing about Taylor and her theodolite measurements and how she was dealing with refraction, and he wanted to get a theodolite to help her out and see what he could see with his theodolite. Then,
so what? I don't understand. Okay, go ahead.
Well, that's the origination of his story. All right. It's not like, I just wanted to prove the globe Earth wrong. No, he wasn't a flat earther until the 27th of January, bro. He had no idea about this conversation in terms of like trying to bring it to an argument to the table. He just happened to help us.
You interrupted me in the middle of my story, and I think it's important to understand.
Because you keep saying, I think Mike did this, but it's not.
Well, here's what I know for sure anybody would do. If you were trying to use a star to determine the elevation of a peak, you would say, "Oh, I can wait until it's occluded, and then I'll simply ask Stellarium how high the star was." That's what you would do.
That's not what he was trying to do. He knew the elevation of the peak. He just got it
Well,
from Wikipedia.
No, I don't mean the elevation. I mean the elevation angle. That's what I mean. He wanted to check that. Now, so you're saying that he thought the elevation of the peak, the elevation angle of the peak should be 2 degrees and 19 minutes. Is that what you're saying?
No,
Well, then
that's
what
not
are
what I'm
you
saying.
saying? Well,
I'm
you said he
telling
was
you.
a globe earther.
Yeah.
Okay, then he would have thought that the elevation of the peak should be 2 degrees and 19 minutes. If he
He had no
didn't, then
idea.
what are
He had no listen. He had no idea about any of that because all he was trying to do was help Taylor out with her theodolite measurements. That's it. So what did he decide to do? Look at the peak of a mountain nearby his house, and he was like,
yeah,
"Huh, 2 degrees 31 arc minutes, or I think it was 32 arc minutes or whatever." And he was like, "That kind of
30.
matches up with the
It's 2
plain
degrees
trig."
30.
Yeah, he was like, "That kind of matches up with plain trig. That's kind of interesting." All right,
Okay.
I'm gonna borrow a theodolite from my stepbrother, a more modern theodolite, and see what angle I get this time. He got 2
Well,
degrees 19.
that wasn't the order in which this happened. That was the last thing that happened. You've left out some things that happened in between.
Okay, but I'm saying where he got the 2 degrees 19 from is because he borrowed his brother-in-law's theodolite. That's how he got
Yeah,
it.
but he knew that the globe Earth prediction for the height of the peak was 2 degrees and 19 minutes. He knew that.
Mm-hmm. Yeah, and he used a theodolite to basically see what would be the angle, and he got the globe angle, and he was like, "Huh, this is interesting. How can we differentiate between the two? Which angle is correct?"
Okay,
Because
so you're saying,
anyone can
can
get
I just
refract.
okay, I get it. Can I just ask? You're saying your claim is that before he ever did the celestial theodolite, he had done both his transit
No,
theodolite
no.
and the. Well, then what are you saying? Would you
I-
please give me the story in the order that you think it happened?
okay, he got a transit. He looked at a mountain peak. Okay, he noticed that it matched plain trig.
Okay, then the first thing he did was the flat Earth calculation for the
Right.
elevation angle. Why would he do that?
What do you mean? Why would he do that?
He's a globe earther. Why would the first thing he did be to calculate the flat Earth elevation angle of Pikes Peak?
Because he
Doesn't
had
make any
two.
sense.
Because he has two claims, right? The Earth is globe. The Earth is flat. How do you prove the difference between the two? So he made a
What is
prediction for
the
flat Earth and a
order?
prediction for
What
globe.
is the
What?
order of the things he did? If
All
he
right,
were a
John.
globe
I'm done.
earther,
I'm
the
done.
first thing
I'm
he
done
would
talking with
do
you.
would be to, okay, you don't have to talk to me.
Yeah.
Look, if
You wonder
he
why you
were a
got
globe
banned. You
earther,
wonder.
if he were a globe earther, the first thing he would do would be to calculate the globe Earth elevation of the peak, which is 2 degrees and 19 minutes.
Dude.
Okay. Now, then he would, you don't have to talk to me. Just shut the fuck up and let me say what I think he would do if he were a globe earther. Then he gets his crappy theodolite, makes an incorrect measurement of 2 degrees and 30 minutes. At that point, if he's a globe earther, he's going, well, where'd that come from? And then maybe he calculated the flat Earth. Maybe he had calculated the flat Earth too. And then he says, wow, what I really got was the flat Earth value. So now what does he do? Is at this, I think you're saying that before he ever did the celestial theodolite, he went out and got a good theodolite. But I don't think that's true. I think the first thing he did was he said, well, how does this work? Because I think what we should do
You're
is a
just making a
celestial
whole bunch
theodolite.
of assumptions, dude. This is
So what
assumption.
you do at this point, is you
Cannot
say,
validate
let's
any of
just
this.
look at
Or
a
assuming,
star. Let's just look at a star. Okay, yeah,
assuming.
I know you don't
Mike
want me to
was
finish.
looking
I
for
get
the
it. I
truth.
get it.
This isn't Beast. This is someone that's listening. You're making a whole bunch of assumptions as to what Mike's intentions were, and no one can know that but Mike. So just stop, dude. It's pathetic.
Yeah, like it changes the result. It's like attacking someone's character, not facing the claim.